Hey everybody, welcome to your first lesson in Algebra 2. I know I said usually we're going to be live, so this is a little bit different than what we're going to be used to and what's kind of going to be normal for us going forward this semester. Typically we're going to have live lessons, but with the check-in and material check-in schedule this week, I had to make these videos ahead of time so that you could watch them while I was doing material checkout and everything like that. So usually we're going to be live. Typically you won't have a video recording of me to watch. But for now, this is what we're dealing with this week. So let's just dive right into it. I don't want this to be any longer than it needs to be. So we'll step right into the math for today. I'll tell you what's going on. So in Algebra 2, where we start, and pretty much one of the main things that we talk about in Algebra 2 for the entirety of the class are these things called functions. We are going to discuss functions a lot in this class. We're going to deal with them a lot. We're going to do a lot of different things about them. We're going to ask questions about functions, how they work, what things we can do with them. We're going to camp out on this idea of functions quite a bit in Algebra 2. So to start today, we're actually going to talk about something that I know that you've seen in the past, something that you might be already pretty familiar with, that might feel like review to you. And if it does feel like review to you, that's great. It's this idea called function notation. Okay, function notation. That's what we're going to talk about in this video. So if this feels like review to you, that's awesome. If you feel a little bit shaky with this, that's okay too. That's why we're starting here. I want to make sure everybody is good with this thing called function notation before we dive into some more complicated things. So what is function notation? How does it work? What do we do with it? That's what we're talking about in this video. So first, let me just tell you, or I guess remind you of some things that you have already done, some things that you've already seen in Algebra 1. Function notation really looks like this over here when we have this f of x. Notice how I said that. It's f of x, not like f times x or f parentheses x. We say f of x. These are two separate problems. They're really the same problem, but just done two separate ways that you're probably familiar with. So if we start over here, we've got this equation, y equals 3x plus 2, and it says to let x equals 5. Well, all that means is to simply, literally, just let the x in this equation be a 5. So you take 5 and you would plug it in for x, and you'd have this equation, y equals 3 times 5 plus 2. All we did was we substituted, or we swapped out that x for a 5, because it told us to let x equal 5. And then from there, we just solved this thing. 3 times 5 is 15. 15 plus 2 is 17, and you'd end up with that, y equals 17. That should feel like review, right? You've probably done quite a few problems like that. Let's throw function notation into the mix and see how it changes things. Big thing to remember here, I'll remind you that f of x really is just the same thing as y. So when you see that f in the parentheses with the x inside of it, f of x, that's really just a fancy math way of writing a y. Okay, so it's not to freak us out, it's not to scare us, throw us for a loop or anything. It's just a fancy way of writing y. So when we have f of x, in this equation right here, when we have f of x equals 3x plus 2, that's really just a fancy way of writing y equals 3x plus 2. We're just using f of x instead, all right? And now what it tells us to do is to find f of 5. Okay, notice how I said that. F of 5. It's not f times 5, it's f of 5. And all that means, this is where you might remember some of this from Algebra 1. All this means, whenever you have f of some number, all that means is that you're going to go up into your equation and you're going to replace x, every x that you see, with whatever number is inside of those parentheses. So in this case, since it's f of 5, I'm going to replace that x with a 5. Okay, so when I come down here, I have f of 5 equals 3 times 5 plus 2. And again, if we solve that, 3 times 5 is 15 plus 2 is 17. So notice how those two problems that we just did are exactly the same. They're just written a little bit differently. Maybe that feels like review to you, like I mentioned earlier. Maybe that feels easy. Maybe that feels simple. Maybe you remember how to do that. If not, that's just a recap of some things that you've seen in Algebra 1. So let's take this idea and build on it a little bit. I'm going to show you something new that maybe might not be as familiar to us. Let's say you have a problem that looks like this. F of x equals 3x plus 2. You're given that function. You're given that equation. F of x equals 3x plus 2. And I tell you, hey, f of x equals 17. Well, this is different than the problems that we just did, right? Before, I gave you an x value. I either said x equals 5 or I said, hey, f of 5. Either one of those things are giving you an x value. Now, instead, I'm telling you what f of x is. Remember, when it's remember, f of x is just a fancy way of saying y, right? So I'm giving you now what f of x or what y is. So what we do, we say f of 17. I'm going to replace f of x. And then this we have 2 equals. I just place f of x with 17. Okay. And there we solve this. We have after this. Let's come up here. Yes. 17. I solve this thing for x. Time to right? Okay. After x equals 17 minus 2, that's 15. Then I divide by 3. X alone. We get first to get x alone. Get 1 by 3. 1 by 3. To get x. 15 by 3. So that's what gives 5. Just a quick recap. You get option number 1. The same way of saying the equation. Okay. You're given a function f of x you are told f of x equals 17. What basically said was if x equals 17, if x is not this number So let's go to x equals -4 in our graph. Okay, so I'm looking at the x-axis. Since it's an x value, I'm going to go to -4. That's right there. Okay, I don't know if you can see that super well, but there it is, -4. And then I'm going to find what my y value is, or what the value of my function, this line, what the value of that line is when x equals -4. Okay, so I'm going to have to go see where I hit my line when x equals -4. And it looks like it hits down here at y equals -8. Okay, so I could say f of -4 when x equals -4, my function, my y value, is -8. Okay, so f of -4 is -8. Let's run through some of these other ones so you can keep seeing it. I'll switch to a different color. Maybe you can, let's see, I'll stick with red. Maybe you can see this a little bit better. F of 0, this one's pretty easy. So this is saying that x equals 0. So I'm going to 0 on the x-axis. Well, that's just the origin, right? And at 0, my line is just crossing straight through the middle of the graph. We call that point the origin. It's not going up or down on the y-axis right there. So that's also just 0. What about f of 1? When x equals 1, well, that's right here. I want to see where my line is when x equals 1. So I'm going to trace up to my line. It's right there. Okay, so maybe like y equals 2. So f of 1, if x equals 1, my function is up at 2. What about f of 2? When x is 2, I'm going to trace up to my line. Looks like it's up at 4. So my function is at 4 when I'm at 2 on the x-axis. Okay, so hopefully you kind of see the process I'm going through. I'm asking, what's the x value that it's giving me? I'm going to that x value, and I'm trying to see which y value my line is at when I'm at this x value. Okay. Well, let's look at these ones down here. These ones are a little bit different. It's kind of the alternative case. Remember, I asked you before, the big question you want to ask is, do you have an x value or do you have a y value? All right. Well, in all these first ones, you were given an x value. But in all these ones down here, remember, f of x is just a fancy way of saying y. So all of these are just giving you a y value, saying y equals 6, y equals 4, y equals 2, y equals -2. And the question that it's asking you is, hey, when y equals 6, what's the x value? If y is 6, where is your function at on the x-axis? All right, so let's see what we can do with this. We'll do this first one together. Well, we're going to do all of them together, but we'll do this first one first. Y equals 6. So I go up to 6 on the y-axis. We'll go blue here. I go up to 6 on the y-axis because it gives me y equals 6. Okay, and it wants to know when y equals 6, what's the x value of my function? Well, I got to go over to where my graph is. I hit my graph right there. And I want to figure out what is the x value, what's the point on the x-axis where my function goes up here to 6. So I'm going to have to go down to the x-axis and see where I'm at. Looks like I'm at 3. So x is 3 when y equals 6. Okay, what about this other one? Y equals 4. I'm going to go up to 4 on the y-axis. I'm going to go over to my graph. Hits right there. And if I go down, I'm going to be at 2. Okay, that's similar to one of the ones we did up here, right? It's just the opposite order. You're given 2 as the x value, and it gives you 4. All right, what about when y equals 2? Go up to 2 on the y-axis, go over to my graph. I hit right there. Again, if I go down, I'm going to be at 1 on the x-axis. What about y equals -2? This one might be a little bit different. I'm going to go down to -2 on the y-axis. That's right there. And I want to see what my x value is. I'm going to go over to my graph, go up to the x value, the x-axis. Looks like I'm at -1. Okay. So again, I just thought through, this was my thought process. I said, these are all y values, right? So when it says y equals 6, I go to 6 on the y-axis, go over to my graph, and I'm asking myself, what is the x value that corresponds with the y value being 6? Okay, we just had to trace over to our graph and then go down to the x-axis from there. right, sometimes this can get a little bit confusing. So if you don't feel like a pro at this right now, that's okay. All right, don't worry about it. We're going to take some time to practice this. I'm just walking you through it, given the intro right now. So if you feel like this is a little shaky, that's totally fine. Okay, I don't expect you to be a pro the first time you see this. We're going to take some time to practice it. All right, so that's dealing with a graph. Let's think again about algebraically, which means you actually have the equation. We're not looking at a graph. We're actually given the equation of our function, and it tells us to solve these things algebraically. So let me walk you through. How we're going to do that. So here's my function: f of x equals negative 2x plus 1. I want to solve each of these things. Okay, so again, I want to the same question is, do I have an x value or do I have a y value? This tells me f of 0. All right, well, remember, if I have f of some number, that's just a fancy way of saying go replace all of your x's with that number. Okay, so f of 0, I'm going to go up here and I'm going to replace this x value with 0. Negative 2 times 0 plus 1, and that's pretty easy, right? If I want to solve this thing down, negative 2 times 0, that's just 0, right? So that just goes away, and I'm just left with 1. So f of 0 is just 1, and then I'm done. Okay, so we're done with that one. Let's think about this one, f of 4. Again, that just means replace your x with this number. So it's going to be negative 2 times 4 plus 1. We got to do a little bit of math here. Think orders of operations. PEMDAS. Right, if you haven't seen that in a little while, PEMDAS. Please excuse my dear Aunt Sally. I've had some students in the past that have come up with some other acronyms for PEMDAS that are not as school appropriate. So maybe if you got one in mind, good for you. Just don't say it when we're live or anything like that. You're going to get me in trouble. But anyways, PEMDAS. We always want to do multiplication first. Negative 2 times 4 is negative 8 plus 1. And negative 8 plus 1. If you need to use a calculator to do negative numbers still, that's okay. You can build up to it. All right, negative 8 plus 1, that's going to be negative 7. So we'd get f of 4 equals negative 7. One more, f of negative 2. Again, all that means is that you want to replace x with whatever number's inside the parentheses. All right, so it's going to be negative 2 times negative 2 plus 1. Just use it up here, replacing negative 2. I think that's positive. Plus 1. Negative 2 plus 1. So, solve simple equation. Make sure you know where to plug in this number set up. Okay. Set up these ones. This is some of the alternative options. So nothing might not be as familiar in this class. So let me walk through now. Go about thinking about these things. We're going to x. This is set f of x equals 0, aka y equals 0. And remember, something like this. If I'm told x equals 0, all I need to do is, hey, well, f equals 0. I'm just going to take x and swap it out for 0. It's the same thing, right? If x equals 0, I'm going to take my equation and I'm going to say that f equals 0. I'm going to switch them. I'm going to say 0. So it out 0 is negative 2x plus 1. And now what this is asking me to do is ask me what's x in this case. It's telling me to solve for x. I'm going to solve for x. So this equation here, I'll say now, if I'm going to x alone, I can subtract 1 from both sides. Might look a little bit strange, but that's totally fine if that cancels. I want to get x alone, so I might have to divide by -2. 0 divided by -2. Only thing divided by 0 is just 0, right? So I get 0 equals x. And I'm all done. Okay? All right, so there you go. On these first problems, you were given an x value. You wanted to take that x value, the number inside the parentheses, swap it out for x in your original equation, and then solve it. On the second half, we were given a y value, right? Or we were given an f of x. So we just took f of x, we swapped it out for whatever the number was, we solved the resulting equation for x, right? Again, if you don't feel like you're good at this yet, that's totally fine. Totally fine. All right, we're going to take some time to practice it. You do not need to be a master the first time that you see it. It's kind of the point of learning. It's kind of the point of growing. You're not really a master at anything the first time you see it. All right, just a couple more things to show you, and then we're going to be wrapping up this video. Let's think. All right, let's see. Do I want to do this? No, I don't want to do that. We've pretty much done this type of problem. I want to move on to this one. It's a little bit more complicated. Spend a little bit more time here. You got kind of an ugly looking graph. Right? It's not a straight line anymore. It's a little more ugly looking, maybe a little bit more complicated. So let's think about how we would deal with this. We'll start here up top. F of 0. All right, remember, when it's f of some number, that's giving you an x value. So it's saying when x equals 0, right, because it starts as f of x. So when x equals 0, where's our function at? Well, just like on the last one, let's go over to the x-axis. Here's the x-axis. Here's the y-axis. We'll go to 0 on the x-axis. That's the origin. And I want to know, where is my function? What's going to be the y value for my function? Okay. Well, I'm going to have to go up to where it hits. Right there, it's up there about at 8. Okay, so I'd say f of 0 is about 8. I know it's a more complicated function, but that's okay. Doesn't matter how ugly the function looks. Once we know our x value, we're just gonna go find where our function's at. All right, let's do another one. F of 2. So I'm going to go to 2 on the x-axis. I'm going to go find where my function is. It's up here, maybe right about at 7, right? So f of 2 is about 7. What about f of 8? I'm going to go out to 8 on the x-axis. 8 on the x-axis, I'm going to go up to where my function's at, right about there. And if I trace over to where it's at, it looks like it's about at 5. And what about f of negative 9? I'm going to go over here to negative 9 on the x-axis. See where my function's at. There's nothing up top, but if I go down, I see that my function is right about there. And if I trace that over, that's about negative 5. Okay. So again, those ones are given an x value, right? F of some number, it's giving you an x value, and it wants to know the y value. I know this graph is starting to look just a little bit ugly here, so I'm going to erase it before we go on to the other ones. Okay. So now on these other problems, this is the alternative case, right? Now it's giving you f of x equals all these things. Remember, f of x is just a fancy way of saying y. So it's saying y equals negative 5, y equals 1, y equals negative 6, y equals 5. And it wants you to tell me what the x value is that corresponds with that. All right. So if y equals negative 5, let's think about that. I'm going to go to negative 5 on the y-axis. That's right here. Negative 5 on the y-axis. And I'm going to trace to wherever my graph is. So if I go this way, there's nothing. But if I go to the left, I hit my graph right about here. And I want to know what's the x value that corresponds with my graph right there. Okay, if you look at it really closely, it doesn't hit. It looks like it should be negative 4. It doesn't hit it exactly, but for the purpose of this lesson right now, we'll just say it does. Typically, if it doesn't cross a number perfectly, I just want you to give me your best estimate. As a decimal is totally fine. Just give me your best guess, but we'll just say for now that's crossing right at negative 4. So it looks like when y is negative 5, my function's over here, the x value that corresponds with that is negative 4. Just about. Okay, what about when y equals 1? I'm going to go to 1 on the y-axis. That's right here. And I'm going to go to where my function is. If I go to the right, there's nothing. But if I go to the left, I hit it right there. And if I trace down to where my graph is at, where my x-axis is, that looks like it's about negative 3. Yeah, so when y equals 1, I'm at negative 3 on the x-axis. Y equals negative 6. Let's think about that. I'm going to go down to negative 6 right here. I'm going to go find my graph. Again, if I go to the right, there's nothing. But if I go to the left, I hit it. This one is definitely right at negative 4. So again, negative 5 wasn't exactly at negative 4, but we just rounded it up for the sake of this lesson. F of 6 is definitely going to get you up to negative 4. Okay. And very last one, y equals 5. When y equals 5, I'm going to go up to 5 on the y-axis right here. And then I need to trace over to get my graph. Notice how if I go to the left, I'm going to hit it right here. If I go to the right, I'm going to hit it right here. But if I keep going to the right, I'm also going to hit it over here. So there's actually 3 points that work for this one, okay? When y equals 5, there are 3 x values that correspond with that for my function. That's totally okay. That doesn't mean we did anything wrong. All right, that's not supposed to freak you out. That's totally okay. All right, no problem there. So let's just think about them one at a time. When I go up to 5 and I go over to the left and I hit right here, well, this definitely is not crossing any number evenly, so that's totally fine. Let's trace down. We'll give it our best estimate. It's maybe like, I don't know, negative 2.3. I don't know, maybe something like that. Just give it your best guess. So we'll say one of my points is negative 2.3. What about over here? When I cross right here, I think that's crossing evenly right there. I can't really tell super well because of my drawing, but we'll say that it is. And if I trace it down, that's at about x equals 3. So we have negative 2.3. I'll write them differently. I won't write them in a list like that. So we have negative 2.3. We also have that x equals 3. Okay, and then if we go all the way over here to my very last point where the graph crosses at y equals 5, if I trace down there, that gets me down to 8 on the x-axis. So I got x equals negative 2.3, I have x equals 3, and I have... So it's feeling weird. That's okay. And watch the go again. Fine if you guys watch it. And sometimes find your local company, whatever you need. You want to master it, for next time practice it. Write it down. Write it your head around. Okay. One thing I have today. Last function is probably my C. If you call it some type of incline or this basically what's saying is that you got G of X of that. Don't let this happen. Here you just check that anything the rules change, anything is different. Everything function is the same. So if you X or 8 of X, it doesn't matter. All the rules are the same as label. Okay. These functions. Once you do that way, each of these switch base to say which node's greater than the other. So that's all we're going to do. So let's do first one. G of 10 and 3. Right. Make sure I plug the right number into the rate function. G of 10, dealing with G. And G of 10 giving the X value. Swap it out for X. Okay, so it's like this. G of 10 equals negative 3 times 10 plus 9. And we'll use 3 times 10 as the X. Beforehand for you guys to watch. So that's it for this video. Please feel free to email me if you have any questions. There will be an assignment posted on Google Classroom along with this video. So let me know if you need any help. Thank you guys for bearing with me, and we will see you soon.